Okay, welcome to the second video for Chapter 4, Lesson 2. Again, just moving on a little bit more with some right triangle trigonometry ideas. We're going to learn a slightly different way of maybe defining how we find our triangle in this video. It's called standard position, and we're actually going to be plotting something on a coordinate plane. So if we ever say, consider this in a standard position, what this means is you can almost call it a leg in our right triangle is going to be on the x-axis, okay, and then generally the hypotenuse of our triangle is going to be directed along some other sort of ray. It says with one ray along the positive x-axis and the other extending into the first quadrant. It's just important that you know it's always the x-axis and then always some sort of ray that they're directing us to. So I think it's going to be easiest to look at an example and just run through that. So it says find sine, cosine, and tangent for an angle in standard position with one ray crossing 3, 4. Okay, so what does that mean? Well, one leg is going to be along the x-axis. Another ray, I guess you call it a ray, is going to 3, 4, and it could keep going on forever. It could keep going to 6, 8. It could go to, what's the next multiple? 9, 12. It could keep going in that general direction, but because we know it's at 3, 4, I'm just going to pretend that, you know what, it stops right there. And then from that point, we always draw a line straight down to the x-axis. So I'm going to try and do that somewhat carefully. There's my line straight down. I want you to think about this right triangle right there. Again, it could have been, we could have had the point going out something like this to maybe wherever 6, 8 is. And if we had made a triangle like that, again, it would have been a similar right triangle. And as we saw in our first video for this lesson, sine, cosine, and tangent with similar triangles, you always get the same answer. So it doesn't matter if I stop at 3, 4 or 6, 8 or 9, 12. I'm going to get the same answers for trig ideas. So knowing that, if we were to quickly switch colors here again, if we were to think about what our side lengths were for the red triangle, again for the red one, this is going to be 3 right there. This is 4 because we know that the point way up on top here, the point that is way right up here, is 3, 4. That's how I get that. And then 3, 4, 5 right triangle. Okay, we all of a sudden have our 3 sides. Okay, the angle is always going to be right here at the origin. And so if I'm looking for, let me shift something over here a second. Whoops, did not mean to do that. Undo. There we go. Okay. So if I want to find sine of theta, sine of theta would be opposite over hypotenuse. That's going to be 4 over 5. Cosine of theta is adjacent over hypotenuse. That's going to be 3 over 5. And tangent of theta is opposite over adjacent. So that would be 4 over 3. Okay, so again, just kind of a repeat of some of the things we did in our first video, but maybe we're describing things in a slightly different manner. Alright, scrolling up. Alright, we have to use our calculator to evaluate some things. There's our fun message again, so we'll just let that pass. You do want to make sure that you go to the mode settings on your calculator, and do make sure that you have it in degree mode. There's another version called radian mode, which we'll get to in a few sections, but you just want to make sure you're in degree mode. So first one's pretty easy. Just calculate cosine of 47 degrees. So cosine of 47. Hit enter. You should get 0.682, we'll say. 0.682. Now part B, it's a little bit more challenging. Cosecant of 53 degrees. There is no cosecant button on our calculator, but what I can do, and this is, again, I should point out, this is going a little bit beyond what our textbook is asking us to do. I just think it's good for us to be thinking about it already, so let me show some of that work right here. For cosecant of 53 degrees, I can easily figure out what sine of 53 degrees is. Okay, sine of 53 degrees is 0.799. I'm rounding there, but approximately 0.799. Let me do the 7. There we go, 0.799. Remember that sine and cosecant are reciprocals. So I could think of this as 0.799 over 1, and that means that cosecant of 53 degrees is going to equal 1 divided by 0.799. You can do that on your calculator right away. Just go 1 divided by your answer if you know how to use the second negative key as the answer option. And we should get 1.252. Okay, so just thinking about this in terms of reciprocals. Okay, sine of theta equals 0.56. That is a different question because now we're trying to find the angle measure. And again, our textbook right now might not ask us too many things about that, but I just want you to start considering it. Hopefully from geometry, maybe you remember this idea of inverse sine. So we could say that theta is going to equal inverse sine of 0.56. Inverse sine kind of undoes this sort of a situation. And I just want you to practice using the keys for that. So if you find the sine button, if you were to go to the second option in that menu, second sine, and type in 0.56 behind it, should get 34.06. So in this case, 34.06. You are actually finding the angle measure now, and that's also going to be very useful long term. Okay, our last question here. Sine of theta equals 1.04. Well, you'd kind of set this up the same way initially. You'd say theta should equal inverse sine of 1.04. But when you do that, your calculator should say error or mistake or something's going on here. And that's to be expected. And I want you to think about it this way quickly. Zoom up here a little bit. There we go. Okay, so in a right triangle, if this is theta, for sine, we're going to be looking at, do a different color here. We would be looking at this red side divided by that purple side. Okay, and if our ratio is going to be greater than 1, it means the red part would have to be bigger than the purple part. But the purple part is the hypotenuse. We know that always has to be the biggest side. So there's no way for sine of theta to ever equal above 1. The red always has to be smaller than the purple, which means our answer should always be less than 1. There is a special case where it can equal 1. But for most of what we look at, it's always got to be less than 1. So that was kind of a trick question, and you should expect an error there. Okay, jot down any questions you might have, and we will see you in class.